Welcome to AST Manufacturing Facilities. My name is Mark Fudge, and I'm the Chief Engineer for the SSC program. The SSC stands for Smart Shelter Container Solution, in which provides data center environments in a box. Actually, in this application, it's not only one box, but it's 3 boxes joined all together. We're talking about boxes of 20-foot container solutions, which are being assembled in order to being deployed in this specific application in the middle of the desert. So we have to take some specifics designs into account in order to have these units perform in this type of environment. In this specific situation, the customer was worried about 2 things. First of all, being in the middle of the desert, therefore providing the appropriate security environment. And then second is to provide an environment which would not look like a data center environment. Therefore, what we did is, first of all, regarding security, we have to provide a vestibule in order to avoid all this dusty environment to go into the IT area. And then we'll go into those 2 containers that we have there, and we have joined 2 containers in order to provide the IT area. So let's get in and have a deeper look. As we enter the vestibule area, this vestibule area has been basically done in order to avoid the dusty environment to come into our IT area. This vestibule has been provided with cooling system together with air renovation system in order to make a pressurized room and avoid entering dusty environment from the outside towards the inside. Besides this vestibule area will be used as well for unpackaging our materials before it goes into the IT area, and also to provide the control units that are needed to work or to make the IT area run properly. So if we have a look here on my right hand side, we have an automatic voltage regulator. Of course, being in the middle of the desert is not an easy environment, specifically for providing a nice and neat power source. Therefore, what we have provided here is this energy or power stabilizer in order to provide the appropriate electrical power. Besides this, and if we turn around, on the other side of this vestibule, what we can find is, for example, an ATS. This ATS will be prepared in order to connect a 300 kVA power generator together with a monitoring system and other systems such as a fire extinguishing control system, as well as fingerprint access control system. So this is the main objective of this vestibule area. We have to imagine now, again, we are on our facilities and this is being assembled. By the way, this has 1 week additional of finally being shipped to final location, and you have to imagine that this container, the vestibule, will be connected to that door that we are facing there. So this hole that we see here on this wall will be perfectly attached to that container in order to provide nice and easy access towards the other side or the IT area. Let's have a look at the IT area. Before entering our IT container, let me show you these doors. I mean, we are talking about being in the middle of the desert. Heat exposure, sun exposure, water exposure. We have all these tight requirements that we need in order to protect ourselves. If we install a basic door, we will not be protecting ourselves. This door has been specifically made in order to survive water flooding together with fire and together with heat. Just keep in mind that this type of solution, the exchange rate, heat exchange between the outside towards the inside, is only 100 watts, being in the middle of the desert. Let's have a deeper look on the inside. Again, this is a specific application for this specific customer, which at the end, what he wanted is an environment in which, in which it was like a data center. It's regular data center, hot and cold corridor aisles. What we have assembled here is basically an area which we call the IT area, 10 racks, 7-8 kilowatts per rack. This was the need of our customer, so this would be low density. Again, with this type of solutions, we can go up to really higher densities. We can provide 30 kilowatts per rack, and if we take a 40-foot container, we are capable to install 20 racks in those type of containers. That would be the most typical application. In this specific case, 10 racks, 7-8 kilowatts per rack, and this two container joint in order to provide a data center-like environment. As you see here down below, I'm standing just in the middle of the container joint. whenever these containers will be joined, no water intrusion, no thermal exposure together with fire exposure will be within this container. So it will be a totally tight and secured environment. If we turn around towards this direction right here, what we see is our services area, that we call it. All these elements right here are fitting our IT area. What we are assembling here, 60 kVAs, double redundancy, there's one UPS still left to be mounted. Again, some cablings, this is under construction, of course. We have the switchboards in order to provide the appropriate power into our IT racks, together with systems for fire early detection system and humidity systems as well for our cooling system. Keep in mind that we are in really extreme conditions in the middle of the desert here, in which we have to control our humidity point as well. If we go into a deeper look in our rack design system, even though these racks standing just without a railing system, as you see here, these racks can be moved back and forth, we have enough space in order to provide good maintenance, easy and good maintenance towards the racks. Nevertheless, our systems, in order to work and be properly assembled inside a container with really, really tight spaces, what we have done is design a specific solution, railing solution, which is capable to withstand 15 kilograms per rack, so you can assemble any manufactured rack, by the way, at any weight that is available now on these days on the market. In order to move these racks, what you have to do is release our braking system and just smoothly run our racks. Again, I mean, we're talking here that this rack is empty, but whenever this rack will be with 1500 kilograms, I can assure you that these racks move really easily in order to provide nice and good access on the front side, and nice and good access as well on the back side, in order to allow appropriate maintenance and cabling into the backside. Again, our main objective, or our customer main objective, is to have a data center-like into a container type of construction. Last but not least, let's talk a bit about the cooling system. The cooling system that we are providing is the same type of environment as in regular data centers. No raised floor, of course. Being shipped a raised floor, what we have to do is minimize the installation time on site. Therefore, ship the raised floor is assembling on site again. Therefore, what we have done is take off our raised floor and just work with overhead fine coil units, in this case, to provide these 8 kilowatts per rack. Air will be blowing on the front side towards the cold tile. Servers will take the hot air and the cold air to make it hot, of course, and then hot air will be up again into the air conditioning, into the overhead fine coil units. Of course, this the solution, we don't only have to consider the solution inside the container, but there will be external elements as well outside the container, such as, in this specific case, cooling towers, in order to provide the appropriate cooling. Therefore, you have seen one of our examples here. I invite you to go into our website, www.ast-global.com, in order to find more information about our Smart Shelter containerized solution. Thank you.